All right. So first of all, I welcome all of you once again to our online tutorials or our online classes. And my name is Dr. Andrews BAHA, and today we are introducing matter. We are introducing matter, and this is integrated science. Integrated science. So I'll not go too deep because you are all not science students. So this is integrated science, and of course, everyone will do matter one way or the other in school. So please, this is the introduction part, and when we are done, we will know what will be there for us to do. All right, so this is matter. All right, so let's look at it, what matter is all about, and everything that we need to know. So, what are our learning objectives? So, at the end of today's classes, you should be able to, one, define matter. You should be able to differentiate between mass, weight, and volume. You should be able to give characteristics of matter. You should be able to mention the building blocks of matter, also known as the particulate nature of matter. Then again, you should be able to differentiate between the forms and the states of matter. Then you should be able to state the kinetic theory of matter. The kinetic theory of matter. So basically, at the end of today, you should be able to answer all these questions. You should be able to answer all these questions. So without wasting my time, let's start right away. And of course, you also need to know the factors that affect the states of matter. Factors that affect the state of matter. All right. So matter. What then is matter? So matter is anything that has mass or weight and occupies space or has volume. So if you have matter, it must contain what? Or it must have mass or weight, and it must occupy space, or it must have volume. That is matter. So if you're defining matter and you don't bring some of these terminologies, then something is missing in your definition. Something is missing. So take note: mass or weight, and then must what? Occupy space, or must have what? Volume. All right. So someone may ask, what then is mass? What is mass? Because we are saying matter must have what? Mass. So what is mass? Mass is just a measure of the amount of matter or the amount of substance in an object. In an object. When you take your phone, for instance, your phone is made up of some substances in them. So a measure of that substance is called what? Mass. A measure of that substance or that matter is called mass. And it is usually measured in grams or in kilograms. So anytime you hear anything that is, let's say 5 kilograms, 5 grams, it means they are referring to mass. They are referring to mass. So that is mass. So mass is simply a measure of the amount of matter or substance in an object. All right. So what then is the weight of an object? The weight. So the weight is simply the force that is acting on the object due to gravity. Now, when we say gravity, we are referring to the force that is applied from upwards, downwards, isn't it? So it is coming from up and it is pressing you what? Down. That is the force of gravity. So a weight is the force that is acting on that what? Object due to gravity. For instance, I can use the phone because all of you are familiar with phones. If I am holding the phone in my hand, or if you are holding your phone in your hand, try leaving it. You realize that the phone will try to come down. This is because there is a force that is acting upon the what? The phone. That is why it wants to fall down. So if you don't put your hand under it, it will fall down. So that is the weight of the object. And of course, it is also measured in what? in Newton. In Newton. Why Newton? Because Newton is what? Is the unit for force. And we are saying the weight of an object is actually what? A force. So it is the force that is acting on the object. So that is what it means to say weight of an object. All right. So volume. So I'm explaining all the terminology so that you understand everything in details. What then is volume? Volume is simply the amount of space that a substance or matter or object occupies. The space that you occupy is what? Is volume. Again, if I put my phone on a table, you will realize that it will take a rectangular space on my table. That space is what is called what? Volume. That space is what is called volume, and it is measured in cubic unit. In cubic unit, that is cubic meter, cubic centimeter, and so on and so forth. So if it is in meters, we can say m to the power what? 3, because it is what? It's cubic. Cubic means to the power 3. All right. So that is meters what? Or cubic meter. Centimeters too, you have cm to the power what? 3. That is how it is to measure what? Volume. So if you see some of these things in your classes or in your workings in school, you should know they are referring to what? Volume. If you see grams or kilograms, they are referring to what? Mass. And when you see Newton, they are referring to what? Force. They are referring to a force. All right. So what have we said in all of these? What we are saying is that matter must have mass or a weight. Again, they must occupy what? Space or must have volume. And lastly, they must contain what? Particles. Like I said, it is a measure of the amount of matter. So the amount of matter is actually referring to what? The particles. So the particles here can be like what? The substances that is what the matter contains. The substance that matter is what containing. So that is what the particles. And as we move on, you will know what these particles are called. That's what we normally call them, the building blocks of matter, because every matter must contain what? Particles. And these particles are the building blocks of matter. So basically, this is just what the introductory part of it. But let's continue to talk more about matter. All right. So now let's classify matter. Let's classify matter. But before we classify, like I said, all kinds of matter are made up of what? Some particles. These particles include what? Atoms. They include what? Ions. And they include what? Molecules. So every particle you see must have atoms, must have ions, or must have what? Molecules. Not at one time, of course. Some can have one particular kind of substance or one particular kind of particle. So it can be atoms, it can be ions, it can be molecules, it can be mixtures as well. All right. So these particles are called the particulate nature of matter. The particulate nature of matter. Other book says the building blocks of matter. So in a school or in an exam, when they ask you what are the particulate nature of matter, or mention the particulate nature of matter, or mention the building blocks of matter, they are referring to what? Atoms, ions, and molecules. Basically, that's what they're referring to. So this particular nature of matter or the building blocks of matter are the particles that are contained in a matter or that are contained in a substance. All right. So these are the substances or these are the particles. All right. So now let's move to the classification. So matter exists in two forms. It exists in two forms. We have the pure substances and then we have what? Mixtures. We have pure substance, and for the pure substances, these are made up of only one type of atom or molecule. they are made up of only one type. So if it is atoms, then it's atoms. If it is molecules, then it's molecules. No mixtures, no blending, only one type. Example is what? Your table salt. Look at the salt in your house. It's made up of only what? Salt. It's not a mixture, right? Sugar can be an example. Elements, elements such as copper, sulfur, any kind of element are all what? Pure substances. They are all pure substances. So you can talk about the helium, you can talk about the carbon, the oxygen, the hydrogen, the nitrogen, whatever you mention. They are all examples of pure substances. Why? Because they are made up of what? Only one type of atom or molecules. Good. And now we have mixtures. Mixtures. So these are made up of two or more different substances which are physically combined. So two or more substances mixed together gives us what? Mixtures. Example, air. You know, air contains what? Oxygen, nitrogen, whatever it is, all combined together. So air is a mixture. Now, alloys. You know, alloys are also what? Mixtures of two or more what? Metals, isn't it? Two or more metals. Seawater. Seawater is a combination of pure water and salt. So if you mix salt with water, you have formed seawater. As simple as that. And that makes it what? A mixture. So over here we can even say water on its own is also what? A pure substance. Water on its own is a pure substance. The salt, like we said over here, is also what? A pure substance. But when we mix the two, it becomes what? A mixture. And again, you can mix gari with sugar. That is a mixture. But gari on its own is a pure substance. But when you combine the gari with the sugar, you are referring to what? Mixtures. So note the difference. So these are the two basic forms of matter. Take note. All right. However, matter exists in three states. Matter exists in three states. What are they? We have the solids, we have the liquids, we have what? The gases. Solids, liquids, and gases. However, there are other types of what? Or other states of matter, and these are the plasma state and the Bose-Einstein condensate. But this is not at your level, so don't confuse yourself with these states of what? Matter. I'm just saying it for you to know that there are other states of matter. But basically, at your level, you need to know solids, liquids, and gases. So in my next slide, I'll be talking about the differences between solids, liquids, and gases. All right. So let's move on to that. So let's talk about the characteristics or the properties of the states of matter. What are the properties? All right. So this is a diagram that I made to summarize everything for us. So we are on the first column, we have our solids. In the middle, we have our liquids. And on the right side, we have our gases. Our gases. So now, in terms of rigidity, we are saying that solids are rigid in comparison to liquid and gases. However, liquid is not so rigid. Gases are not what? Rigid. So please note the differences between them. Solids are very rigid. Liquids are not that rigid compared to solid. However, they are more rigid compared to what? Gases. But gases are not what? Rigid. Second point is that solids have definite shape and volume. Why? Because they are rigid. And because they are rigid, they have a definite shape and a definite volume. What about liquids? Liquids do have a definite volume, but they do not have a definite shape. They only take the shape of its containing vessel. For example, when you have water in a bottle, you realize that it is taking the shape of the bottle, but it doesn't mean that liquid are having a definite shape. No, they have a definite volume, but they do not have a definite shape. They only take the shape of its containing vessel or its container, basically. Now, what about gases? Gases neither have shape nor volume. They do not. Why? Because they are not rigid. Again, solid particles have low kinetic energy. When I say low kinetic energy, I'm referring to what? Movement. Movement. Now, because solid are very rigid, they are not able to move about what? Freely. And if you're not able to move about, you have a low kinetic energy. Now, liquid are of what? Intermediate. Intermediate. Whilst gases possess very high kinetic what? Energy. Why? Because they are widely apart, they are not rigid, they can move what? Freely. So they have very high kinetic energy. Solids, very low. Liquids is intermediate. All right. Now let's come to compression them. So in terms of compression, solid cannot be compressed easily. You can't compress it because it's very rigid. What about liquid? They can be compressed, but gases can be compressed so easily. So what? Easily. All right. So in terms of comparison, liquids can be compressed, but not as in gases. For gases, they are easily what? Compressed. Again, let's look at the molecules that are between the solid. So the molecules are held tightly together by what? Strong force of what? Attraction. Strong force of attraction. Why? Because they are very compact. So because they are very compact, the force of attraction between them is very high. Very high. Whilst liquid have what? Intermediate level of force of attraction. And gases have the weakest force of attraction between the molecules. The weakest. Again, solids are or they have very high what? Density because of their compact nature or their rigid what? Nature. So in terms of density, solids are high. In terms of density, liquids are of intermediate level, and gases have very low density. Very low density. Again, because solids are rigid and compact and they have very strong force of attraction with low kinetic energy, they cannot move easily. They cannot move easily. But of course, liquids are known by their flowing what? Property. For example, when you pour water on your table, you will realize it will move. It will move to the other side. It will move. However, what about gases? Gases flows and even what? Evaporates easily. They flow and evaporate easily. What about diffusion rate? So the diffusion rate is very what? Low in solids. In liquids, they are moderate or they are of intermediate level. But with gases, they can easily what? Diffuse. It's just like smelling the scent of an ammonium gas. Yeah, easily it will spread because it is a gas. It is a gas. All right. So easily it will what? It will spread. Look at the odor of a fish. You see, easily it will spread. Why? Because it's a gas, and gas diffuse what easily. That means they're able to move from one place to another. That's from a higher concentration to a what? A lower what? Concentration. That is how this is. So I believe this is just a summary of the differences between solid, liquid, and gases. Solid, liquid, and gases. And in this one, in exams, when they ask you these questions, you should just get it one time, boom, and you're gone. All right. So basically, that is just it for the characteristics. But of course, let me give you another diagram to appreciate it better. So now look at this. Look at the compact nature. They are solid, are very, very well tight. So they are what? Rigid, fixed shape, fixed volume. You can't compress it what? Easily. You can't. Now look at liquid. You see, they are a little bit what? Apart from each other, a little bit apart. So they are not as rigid as in solid. But of course, they are more rigid than gases. They have no fixed shape, but look at it. It is taking the shape of the containing what? Vessel. They also have what? Fixed volume. Again, they can be compressed, but with respect to solid, of course, they can be what? Compressed. But with respect to gases, they are not easily what? Compressed, right? Exactly. Now look at gases. Look at the particles widely apart from each other, widely apart from each other, widely apart from each other. So they have no fixed shape, no fixed volume, and they can be compressed easily or squashed easily. So basically, these are just the summary of the characteristics of the state of matter. All right. So let's look at some few examples. Some few examples of these states of matter. Some few examples. What do we have here? Look at this, solid. So anything that you see around you, pencil, skateboard, snow, apple, computers, bicycle, table, your phone, your curtain, everything in your room, I think you can identify some solid over there, right? Exactly. Let's move to liquids. So liquid, you have what? Poo or water in the pool. You have hot chocolate. You can have your drinks. Some of you have some pineapple juice in the fridge and stuff like that. You have some milk there. You have some soup. I know some of you are preparing to eat your wonderful dinner, or let me say supper. So the soup is already prepared. Some of you are waiting for that fufu. So the fufu in itself is a solid, but the liquid, I mean the soup on it, of course, will be what? Will be liquid. Rain, mention them. Mention them. Those are the examples. What about gases? Of course, air is a gas. Uh, the hot air, balloon, the steam. Those who cook, who like cooking, sometimes you can see vapor coming out of the food, isn't it? Yes. All of those are all what? Gases. The fog in the middle when you wake up at dawn, then you will see some fog. All right. Then the wind. Some of you are under ceiling fan. Check it out. So all those things are all what? Gases. So basically, this is just a summary of examples of matter or examples of solids, liquids, and gases. All right. So now let's move to the kinetic theory of matter, also known as the particle theory. The particle theory, the kinetic theory. So what does it state? Or what does it say? So the kinetic theory of matter says that all matter consists of many very small particles which are constantly moving or in a continual what? State of motion. What does it mean? All that is trying to say that every particle or every matter consists of what? Particles. And these particles are very minute. They are very small. And you can't even see them with an unaided what? Eyes. You can't see them with unaided what? Eyes. All right. And again, these particles are in constant motion, or they are moving continually. So the particles that you find in solid, they are moving. The particles that you are finding in liquid, they are also moving. The particle that you are finding it in gases, they are also what? Moving. But of course, depending on the nature of matter, you will realize that this one has a very low kinetic what? Energy. The other one has what? Intermediate. And gases have what? The highest kinetic what? Energy, which means that they move what? Faster. They move faster. But know that this matter, which contains all these particles, their particles are in constant motion, or they are always what? Moving. They are always moving. So this is the theory, or that is the particle theory, also known as the kinetic theory of matter. Kinetic movement. Kinetic means movement. So again, it says that all matter consists of many very small particles which are constantly moving or in a continual state of motion. In a continual state of motion. So basically, that is just what the kinetic theory of matter represents. Again, the degree to which the particles move, I've already said this. So the degree to which the particles move is determined by what? The amount of energy that they have and their relationship to other particles. Of course, it depends. For example, if you are having a hole, this will be much better. Look at when you are cooking, the ladies around, when you are cooking, when you send your hand towards the stove, which is actually on fire already, you realize that you want to move your hand, right? Why? Because heat is coming, isn't it? Exactly. That means that the particles near your fingers or near your hands are beginning to gain what? Momentum, or they're beginning to have a higher amount of what? Kinetic what? Energy. And that's why you have to move your hand very fast. Exactly. So that is how the kinetic theory of matter is all about. All right. So it deals with the amount of what? Energy that they have, and of course, their relationship to other particles. When you take solid, you know that they are closely what? Together. And if they are closely together, that means they cannot move freely. But if they are far from each other, it means they can move what? Easily. It's like being in a boarding school. You are confined in the walls of your school, so you can't move freely. You can't move and go to town and do whatever you want, isn't it? Yes. So we can liken you to what? To let's say a liquid. Though you can move within, but you cannot really what? Move and express yourself like a gas. Just like now that you're in the house, perhaps you can go town, you can go to town, you can visit your friends, you can make calls, you can do everything you want. It means the level of freedom is what? Is increased. So you are like what? A gas. You are like a gas. So that is how these things play. So if you understand it that way, everything you will understand it, or you will get it. Again, so like I just said, so as temperature rises, the particles get what? Hotter, and they begin to have more what? Energy to move around faster. I've already explained that. And again, when particles are further apart, they move what? Freely and faster. So these factors affect the movement or affect the kinetic theory of matter. So when I ask you, what are the factors that can affect the kinetic theory of matter? What comes to your mind? Of course, temperature. What comes to your mind? Relationship, or the closeness of what? Of the particles to each other, right? Yes. So basically, that is just it for the kinetic what? Theory of matter. But again, why do we study this kinetic theory of matter? So this theory helps us to explain the properties of what? Matter. If you realize, when you go back, you will realize that all the properties of matter were dependent on what? On the kinetic theory of matter. Kinetic theory of matter. So it explains the relationship to other particles. It's explaining the amount of energy it is having and all of those things. So it explains, or it helps us to understand the properties of matter. And again, it helps us to know what happens during physical what changes of the state of matter, just such as melting, boiling, and what? Evaporation. So for example, if you are melting a substance, that means temperature might what? Might increase. So you begin to understand, oh, okay, now that the temperature has increased, what is happening? It means that the substances begin to get what? Hotter. They begin to get what? Energy, which means they will move what? Faster. Am I right? Good. And again, when you cool, when you are cooling a substance, or when you are cooling anything to, just like normal water you put in the freezer, you are cooling it. The water will now become solid, isn't it? Why? Because you are cooling it, temperature is reducing. And when temperature reduces, particles get what? Colder. When the particles get colder, they will have low what? Energy. When they have low energy, they cannot what? Move. They cannot move. And that is where a liquid can become even what? A solid. Why? Through the process of what? Cooling, or through the process of what? Freezing. All right. So all of these things help us. So this kinetic theory of matter help us to explain some of these things and help us to understand them much better. Much better. So please note them, and yeah. All right. So some few facts about matter, and I think we'll be done for today. So some few facts about matter. So certain things have names but are not matter. Example is light. So light has a name, but it is not matter. So take note. Something can come in your exams. Which of the following is not an example of matter? But we all know that everything that is surrounding us is made up of matter. But hey, light is not an example of matter. Why? Because light is made up of electromagnetic radiation, which is actually a form of energy. And you know that energy neither have what? Mass, nor occupies what? Space. Energy doesn't have any mass, it doesn't have what? Space, or it doesn't have what? Volume. Isn't it? Yes. That is why you can't describe light, and for that matter, energy, as a form of what? Matter. As a form of matter. All right. And again, the idea that everything is made up of moving particles is called what? The kinetic theory of matter. I think this one has been well explained already. All right. And again, the state of matter can be changed from one form to another form depending on some factors. Like I was saying it in the previous slide, I said what? When a substance gains energy or gains temperature, temperature will rise. When temperature rise, the particle or the substance become what? Hotter, begin to get what? Energy, and it begin to what? Move around, isn't it? What it means is that based on this understanding, one substance can change from one state to another state, which means we can change a substance from solid to liquid, from liquid to gas, or from gas to liquid, from liquid to solid. Isn't it? Yes, we can. And that is what we'll be talking about in our next class. In our next what? Class. So you don't want to miss that. So what are the factors? Basically, it depends on what? The materials, it depends on the temperature, and it depends on the pressure. Material, temperature, pressure. We shall talk about it in details in our next class or our next tutorial. So please stay tight and don't go away. And Try and be part of what is happening. Don't miss any of these things for anything. All right. So basically, that brings us to the end of the introduction to matter. And our next topic here will be what? The change of state of matter. Change of state of matter. It is something you don't want to miss. So this is what we'll be talking about: solid to liquid, liquid to gas, or gas to solid, or whatever to whatever, whatever to whatever. That's what we'll be talking about in our next class.